Let's now look into the different operations on matrices, the first of which is matrix addition. If we have a matrix A and matrix B and they are of the same size m by n, then their sum is the same size m by n matrix given by A plus B is equal to the sum of each of the entries. And the sum of two matrices of different sizes would be undefined. So, let's take a look at these examples. We would have the first one in letter A. So, let's take a closer look. There you go. Let's just move that a little bit, a little far. There you go. Alright, so first we need to check if they are of the same size, because if they're not, then their sum is undefined. As we can see here, they are of the same size, 2 by 2, so we can add them. According to the definition, their sum would be a matrix form by adding each of the corresponding entries. So, if we're going to have 1 plus negative 1, that would be 0. 2 plus 3 would be 5. 0 plus negative 1 would be negative 1. And 1 plus 2 would be 3. So therefore, the sum of these two matrices would be the matrix 0 with the entries 0, 5, negative 1, and 3. Now, it's your turn. Let's zoom this out. Oops. There you go. So, pause the video and try to see if you can find the sum of B, C, and D. Alright, so first for letter B, we can say that we can add them because they are both 2 by 3 matrices, and luckily the other matrix is just all zeros in the entries, and if we're going to add each entry to 0, it will come up just the same. So therefore, we can say that the sum of these two matrices would be 0, 1, negative 2, 1, 2, and 3. So there we go. In letter C, if we are going to double check, we can see that there are actually the same size, 3 by 1, 3 rows, 1 column. And if we're going to add them, we're going to have 1 plus negative 1 is 0, 3 plus negative 3 plus 3 is 0, negative 2 plus 2 is also 0. So the result is a 3 by 1 matrix whose entries are all zeros. Letter D. As we can see, letter D is a 2 by 3 matrix, but the second matrix is a 2 by 2. This is a 2 by 3, and this is a 2 by 2 matrix. Therefore, their sum is undefined, meaning we do not know, or the sum of these matrices are not defined because they are of different size. Now, another important operation would be scalar multiplication. Take note that when we work with matrices, real numbers are called scalars. So if we have a matrix A, it's an m by n matrix, and C is a scalar, then the scalar multiple of A by C is the m by n matrix given by CA is equal to C times each entry of the matrix. So it is often convenient to rewrite the scalar multiple CA by factoring out C out of every entry in the matrix. So for example, we have this matrix here, and it looks like 1/2 that scalar was factored out, so we're going to have 1/2 multiplied by the matrix with the entries 1, negative 3, 5, and 1. So this is an example of scalar multiplication. Now, scalar multiplication is defined first so that we can define another operation, which is the subtraction of matrices. Now, the matrix negative A can be used to represent the scalar product negative 1 times A. Now, why do we need to do this? Because subtraction as is meaning if we're going to just have A minus B is not defined in the set of matrices alone. However, if negative A can be represented as negative 1 times A, hence we can define this in terms of addition of matrices. So therefore, A minus B can be A plus negative 1 times B. Although this will later turn out as if we're just subtracting numbers, we have to be extra careful because matrices are different objects than numbers. So let's have an example. We're given with matrices A and B and we're asked to find 3A, negative B, and 3A minus B. Pause the video and try to see if you can apply the definitions of scalar multiplication and matrix subtraction. Alright, so first let's find 3A. So this is an example of scalar multiplication. So we're going to multiply 3 to all the entries of matrix A. And doing that, we would have the following result. The matrix will now become 3 times 1 will be 3. Oops, my bracket is a bit small. Let's change that. There you go. And now I'm going to have 3 times 1, 3, 3 times 2, 6, 3 times 4, 12, and so on. And I'm going to have negative 9, 0, negative 3, 6, 3, 6. So this is my matrix 3A. Now, for letter B, which is the negative matrix B, this is negative 1 multiplied to matrix B, 2, 0, 0, 1, negative 4, 3, negative 1, 3, 2. There you go. And this would be multiplying negative 1 to everything. We just need to change the sign. So this becomes negative 2, 0, 0, negative 1, 4, negative 3, negative 1, 3, and 2. Finally, we are then asked to find 3A minus B. So, if we're going to find 3A minus B, that is the same as saying we're going to have 3A plus negative B or negative 1 times B. In other words, we are supposed to add our 3A on top, which is our 3, 6, 12, negative 9, 0, negative 3, 6, 3, 6. We need to add that to already our negative B, which is negative 2, 0, 0, negative 1, 4, negative 3, negative 1, 3, and 2. So therefore, we're going to get this matrix 1, 6, 12, negative 10, 4, 0, and then 5, 6, 8. And there you go. These are examples of the different operations on matrices: matrix addition, scalar multiplication, and matrix subtraction.